Welcome back, my fourth graders. Today's lesson is 5.4, use partial quotients. Our target is use partial quotients to divide. Sounds familiar, isn't it? Because partial products we were working on, partial products are what? Part of the product. Yes, you need to add all the partial products to find out the product. Now we are going to use what? Partial quotients, which is what? Part of quotients. Yes. And you are going to use what? All the partial quotients to find out actual quotient. That's what we are going to do. And remember, guys, always division is inverse operation of multiplication. All right? And we can use this division fact to find out the quotient for the division problem. All right? So look at this, guys. This is familiar. We split this, we break this apart, this number into 10 plus 2, and here 10 and 2, right? And 3 times 10 is 30, and 3 times 2 is 6. We know this so easily. We are good at area model, right? So we are going to use what? This fact to find out the quotient. So look at this, the bottom side. 3 times what number is going to make 30? We know easily, it's 10. And 3 times what number is going to make 6? 2. You see this? 10 and 2, they are partial quotients, okay, in this division problem. And when you add these two partial quotients together, you are going to get 12, which is a quotient. All right. Now, how does the distributive property relate to each of the area models? Explain. The area models show an example using the distributive property because why? We use breaking apart the number, right? So we can say we broke we broke apart the number into 10 plus 2. And then you distribute what? 3 into 10 and 2. Add them together. So I'm going to write down this 3 times 10 plus 2, parenthesis, right? Is equal to what? Delivery, and to delivery is 3 times 10 plus 3 times 2. Okay? Alright. Now let's move on. To divide using partial quotients, subtract. Remember, guys, subtract. Because multiplication is what? Repeated addition. But this division is repeated subtraction. We learned this last year. Remember? Right? So division is what? Repeated subtraction. Now subtract a multiple of the divisor that is less than the dividend. Less than the dividend. This is really important. Okay? It shouldn't be the greater. And I told you what is my preference quote. Yes, what multiple of the divisor is close to this dividend but not greater. Please always remember that. And then you need to continue to subtract multiples until the remainder is less than the divisor. Okay, so until you have no like smaller piece than equal groups. Okay, we practiced it last lesson. Please remember that. If you have greater number, more remainder than the divisor, that means what? You can still distribute equally into equal groups. Okay, so this remainder has to be less than divisor. Please remember, okay? All right, the factors that are multiplied by the divisor are called partial quotients. Okay, their sum is the quotient. So you need to add the partial quotients to find out the quotient. Now, let's look at this example. Now, we are going to use an area model and partial quotients to find 235 divided by 5. All right, one way and another way, we have two different ways, right? But they are same strategy, similar to, okay? Suddenly why this is not the, okay, sensitive. Okay. All right. So now they use what? They split this 235 into what? 100 and 100. Okay, plus 35. Okay, so 5 times what makes 100? Yes, we know 20. That's what in here. Okay, and then 5 times another number is gonna make 100, which is what? Same 20. And then 5 times one number is gonna make 35, which is what? 7. And then when you add all together, 47 you are going to find. And this area model, they put this in here, only the numbers. That's what partial quotient is. Okay, so 235 divided by 5 is what? 47. Okay, now another way, let's take a look. Instead of dividing this 235 into 100 plus 100 plus 35, they use what? 200 together plus 35. You see, 200 plus 35. Now we know 5 times 40 is going to make 200 because 5 times 40 is 20 and you need to add one more zero. Okay, and then 5 times 7 is 35. So our quotients are what? 40 plus 7, 47. And this area model is where? Here, only with only the numbers. Okay, 47. So let's practice more with another problems. So use an area model and partial quotients to divide. 60 divided by 4 is what? That's the question. Okay, so we know 4 times 10 is going to make 40, right? And when you subtract, you are going to constantly subtract until you have lesser remainder than the divisor, which is here divisor is 4. Okay, so when you take away, this is going to be 20, and we know 4 times 5 is going to make 20. So yeah, 5 times 4, 20, and when you take away 20 to 20, it's going to be 0. So our partial quotients are what in here? Yes, 10 and 5. When you add them all together, it's gonna be 15. Now let's use this area model, which is familiar to us, right? And 4 times what's gonna make 40? Yes, 10. And 4 times what's gonna make 20? Yes, we know 5. All right, let's move on to number 2. Let's use our partial products first. Okay, I mean area model first, because I think this is easier for us. We know this 3 times what makes 180. Since 3 times 6 makes 18, we are going to need to add only one more zero. So 3 times 60 is what? 180. And what is left over when we do this 180 take away? You are going to have only 12. And since we know 3 times 12 is the remainder, right? From the area 192, right? 3 times what is going to make 12? Yes, 4. So we know 4 and 60 is going to be no remainder. So 60 plus 4 is 64. And the quotient is what? 64. 60 and 4, they are partial quotients. And then 64 is the quotient. All right? And you can use area model or just this long division, long repeated subtraction model. Whichever you feel comfortable, you can go ahead. Now use an area model and partial quotients to find 264 divided by 8. Since we know 8 times 3 is making 24, and there is 1 0 here, we know this top is what? 30, because 8 times 30 is what? 24, and add 1 0. I mean 8 times 3 is 24, sorry. Alright, now what is left over after when you take away 240 from 264? Yes, we are going to have 4 and 2, 24 left. Oh, we know already, we did it, same. 8 times what? 3 is 24. Okay, So our partial quotients is what? 30 and 3 is going to be what? 33. I'm going to erase this one because I know some of you guys might confuse because a line, right? We mentioned about it. Yes, ones place goes ones place and tens place goes tens place. All right, so you okay with this? Yes, so our quotient is what? 33. All right, now use partial quotients to divide. Okay, so do you want to draw this area model? Go for it. 4, and I'm going to split that into what? Since I know 80 is multiples of 4, right? So I'm going to use 80, and rest of them are what? When you take away, you are going to have 16. So 16 is another part, right? So I know 4 times what makes 80? Yes, 4 times 2 means 8, and then add one more 0. And then 4 times what number is going to make 16? Yes, 4. So look at this. This is what? 4 times 20, and this is what? 4 times 4 is 16. There's no remainder. So when you add this together, it's gonna be 24. Alright, now I'm going to use this area model again, 9, and split this in half. Alright, what is close to 40? I'm going to work on these first 2 digits first, okay? What is closer to 40 but not greater from multiples of 9? Yes, you know, 36, right? But this is not only 36, but this is what? 36 tenths. So I need to add 1 0. 9 times 4 is 36, and add 1 0. What is the difference? Okay, 5 take away 0 is 5. Okay, so since you cannot take away 6 from 0, you need to borrow it from hundreds place. It becomes what? 3, and it becomes 10. 10 take away 6 is what? 4. So this is 4 is another area, partial area, let's say. All right, 9 times what number is going to make 45? Yes, 5. So now I'm going to put this here, 9 times 40. And this one is what? 9 times 5 is 45. Take away, nothing left over. And when you add them all together, it's going to be what? 45. Okay. Let's move on to number 6. 378 divided by 6. Okay, I'm going to use another area model here. 6, and I'm going to split them into 2 groups. And what multiples of 6 is closer to 37? Okay, first 2 digits we learned, right, when you estimate. What is closer to 37 but not greater? Yes, 36 we know, right? And then since this is not only 36 but 36 tenths, I'm going to add one more 0. 6 times 6 is 36, and add 1 0. Okay, and what is left over? 8 and 10. So 18 is leftover area, partial area, right? So now 6 times what is making 18? Yes, 3. Okay, so the answer is what? 63. I skipped the part, this one in here, since we know already this is what? 6 times 60 and 6 times 3. When you add them together, it's gonna be 63. Number 7, 84 divided by 7. Okay, so since I know 7 times 10 is 70, let's work that one first, right? So 70, 7 times 10 is 70, and then what is left over? Yes, 14. I'm going to put 14 in here, and 7 times 2 is gonna be 14. And when you take them away, you don't have anything left over, which means what? 7 times 10 and 7 times 2. 10 plus 2 is 12. That's the answer. And let's move on to this this number 8. So since I know 5 times, let's say, I'm going to split that into 2 first. When I take a look at this number, this is way bigger than 500, right? Which means what? 5 times 100 is going to be 500. Okay, so I might need more space, more areas, more partial areas, right? But I'm gonna go ahead, since we can always add, okay, whatever we have, which is what? 500. I'm going to take away. See, how did I get this one? 5 times 100, right? That's 500. So when you take them away, it's gonna be 5, 3, 2. And I know I can split again, right? To know what? 5 times 4 is gonna make 20. Make sense? But it's gonna be what? 20, but it's 20 tenths. So 40 is going to make 200. And I'm going to find out what is left over is 35. So this is another partial area, which is what I know. 5 times 7 is making 35. So 35, when I'm taking away, I don't have any remainder. So that's going to be what? 5 times 40 and 5 times 7. So you need what? To add this. Okay, factors. This means 147. Easy, right? Yes, when you see this model, like area model, it's getting easier, okay? And it won't have any problem since we are good in this area model. Okay, number 9, find the missing numbers. Okay, so 4 times what is gonna make 24? That's what they're asking for, right? And we know 4 times 6 is 24, and how many extra 0? Yes, one more 0. So this 60 is what? Partial quotient, okay? And 4 times what makes 8? Yes, 2. And how many 0? 1 0. So that's another partial quotient. And 4 times what makes 12? Yes, we know 3. So 3. When you add them all together, 3 and 6 plus 2 is 8. So 83 is the quotient. Easy, right? It's not that hard. Did I say you need to pause your video? I don't remember. Maybe I didn't. But you know, always. First two pages I practiced together with you, but third page and fourth page I want you to try by yourself, and you can come back and check your answer with my video, okay? That way you can improve your math skills a lot better than just looking at the lesson, okay? So please keep that in your mind, okay? Please take your time and try. If you don't get it, rewind the video and watch it over, all right? Okay, example. There are 8 students on each tug-of-war team. How many tug-of-war teams are there? Okay, tug-of-war, maybe we need to use this table, right? Tug-of-war, we have what? 128. Okay, use an area model and partial quotients to find 128 divided by 8, since there are 8 students on each team, okay? So we know they gave us already what? The closest, close to 12 is what? 8, right? 8 times 1. And then this is not only 8, but 8, 10. That's why they put one more 0 here, 10. Becomes 10, right? And then what is the difference between 128 and 80? Yeah, it was 48. So 48, right? So we know the multiples of 8. 8 times 6 is going to be 48. So 6 is our partial quotient, sorry. Okay? And then when you add them all together, 16. That is our quotient. Okay? And you can also use what? Area model, like bottom in here. 8 times 10 makes 80. And then what is left over? 48, right? From the dividend. Okay? And we know 8 times 6 is 48. So when you add these partial quotients together, you get 16, which is the quotient. There are 16 tug-of-war teams. All right, let's move on. Use the table above. Okay, we will. All right, there are 5 students on each relay race team. Relay race, okay, 90. Okay, let's keep that in your mind. Okay, 90, and there are 5 students on each relay race team. How many relay race teams are there? Okay, in each team has what? 5. 90, sorry, I forgot. Okay, now let's find out. I'm going to split this into this area model, okay? I'm going to use 5 times. Since I know 5 times 10 is what? 50. Okay, take away 50. What is it? Yes, 40 is left over. So 40. 5 times what? It's gonna make 40? 8. So these are what? Partial quotients. Now let's add them together, which is 18 teams. It was easy, right? All right, let's move on to number 11. There are 6 students on each volleyball team. Okay, 6 students on each volleyball team, and there are 4 fewer students on each water balloon toss team than each volleyball team. How many of each team are there? Okay, let's find out. So first of all, let's find out the volleyball team, which is here. 96 students are playing volleyball, and then 96, right? Yes. And then each team has what? 6 students. Okay. Now I'm going to say, I'm going to draw this area model. 6 into 2 pieces first. I'm gonna see. Since I know 6 times 10 is 60, I'm gonna take away 60, and I'm going to have 6 and 3, 36. This is 36 is what? Partial area now. Now 6 times 1 is gonna make partial product. Partial product here, right? 6 times what? Yes, 6 is going to be 36. So volleyball teams, I don't have space, so I'm gonna put it in here. How many teams are there? 10 plus 6, which is 16 teams. Okay, what about this? What is it? The water balloon toss team. Okay, let's go ahead. Water balloon toss team. Wow, 156 students won it. Okay, 156 divided by what? There are 4 fewer students on each team than volleyball team, right? Which means what? 6 take away 4 is 2, right? Because 4 fewer than this volleyball team. So 2, I'm going to draw a model. And since I know 2 times 7 is going to make 14. Okay, 14 tens, right? I know what is left over. 16 is left over. Make sense? Okay. Now 2 times 8 is gonna make 16. So I got all the partial quotients, which is what? 78. So water balloon team is what? 78. Since I know partial quotients are 70 and 8, so I can add them together simply, right? Teams. This is the answer, guys. Okay, we didn't have enough space. I wish they gave us, enough space to work on, right? They always do this. I don't like it. But I don't complain, guys. Let's go ahead. Number 12. 20 students were absent on the day of sign-ups. Okay, 28. Okay, now they all decide to pick kickball. Okay, there are 9 students on each kickball team. How many kickball teams are there? Okay, so you need to simply add 28 to how many students are in kickball, sign up for kickball? 107. Okay, plus 107. Okay, let's go ahead. 7 plus 5 is, 8 plus 7 is what? 15. I'm going to carry 1 up. 1 plus 0 plus 2 is 3. And then 1. So total 135 students are playing what? Kickball. And in each team, they have 9 students. Okay, so how many teams are there? That's the question. So I know I'm going to use this partial area model. 9 times 10 is 90. I'm going to go for that first. So I'm going to take away 90 first. 5 you cannot take away, right? So you are going to have 13 anyway, but I'm gonna write it down this way anyway. 13 take away 9 is what? 4. 45, which is what? I know. 9 times 5 is going to be 45. So I got the partial quotients. Now I'm going to add them together to get my actual quotient, which is what? 15 teams. That's it, guys. This is fun to play and practice. Okay, so I want you to practice this partial quotient strategy more. Okay, this is gonna help you more to understand how to find the actual quotient. Okay, and your homework, 221 and 222. Okay, all right, that's all. I will see you guys tomorrow. Bye.